Hello, and welcome to this CodeRage 9 C++ Builder session on Application Tethering for VCL and FireMonkey using Wi-Fi and Bluetooth. My name is Mannarino, and I'm one of the Embarcadero software consultants. For this session, we'll look at the features that App Tethering provides. You can easily extend your existing Windows VCL and FireMonkey apps to connected devices, sensors, data, and services using Application Tethering. You can use the CBuilder XE7 runtime library, App Tethering components, that will give your applications the ability to interact with other applications running either on the same machine or on a remote machine. We'll see how easy it is to auto-discover other applications that are using App Tethering, running either on the same device as your application or on other connected devices. And with App Tethering, your application can publish actions, and then other applications can remotely invoke any of the actions on the former application. You can use App Tethering to share data between applications. App Tethering allows sharing of standard data types and streams. And lastly, you have the choice to either use Bluetooth or Wi-Fi for your App Tethering. So, what is App Tethering and why use App Tethering? Well, devices, gadgets, and wearables are changing the way we experience and interact with devices. Apps are no longer standalone but distributed among devices, gadgets, the cloud, and data. So these are the new user experience elements. So today we are surrounded by all of these gadgets and wearables, and they all can be controlled through the internet or Bluetooth. So for example, we have Bluetooth and Wi-Fi, heart rate monitors, security systems, temperature control systems, point of sale systems, lighting systems, Google Glass, etc. Every different type of market has some type of Bluetooth and Wi-Fi enabled device. So for example, a Bluetooth restaurant ordering app changes the traditional way that is still used in restaurants, which relies mainly on the waiter to come and take care of the customer's orders. So creating an alternative system that allows the customers to order using Bluetooth technology on their mobile phones is both time and effort saving, especially in the rush hours in big restaurants when the waiters are forced to take the orders from a wide range of customers all at the same time. So this way, the customers input their orders onto their mobile phones using Bluetooth. The orders then get sent and confirmed by the main server and enter the order list to be served soon enough. App Tethering extends your reach to these gadgets and wearables and your existing VCL and FireMonkey applications. App Tethering opens easy communication between applications, devices, gadgets, and wearables, and no server is required. So Application 1 can talk with another instance of Application 1. Now, one of the main concepts of App Tethering is discovery and connection to companion applications. Automatic discovery is important and no configuration is needed. So you do not have any configuration hassles. Like we see here on the slide, one of the main goals of App Tethering is to have companion apps. Like I can have my VCL and FireMonkey desktop apps talking to a different companion device application, or even more than one depending on the user role. It's also important to say that mobile apps do not need to be involved at all. So for example, you can make a Windows service that is a receiver from the desktop application running on the same subnet or a different subnet, or be Bluetooth connected. So an example could be a point of sale system running on various devices talking to the same receiver without needing to implement multiple communications protocols. Another example could be a Google Glass app that can control aspects of an existing Windows app. The app tethering feature does not depend on a specific transport or protocol, and new protocols can be implemented using the App Tethering API. In XE7, the RTL provides built-in support for both Ethernet or Bluetooth connections between applications on the same local area network, or connect to devices in different subnets or devices with completely different IP addresses, including applications running on the same device. So there are all kinds of Internet of Things devices that we can now connect to using XE7, and XE7 makes it very easy to implement. You can now breathe new life into your existing Windows apps by extending Windows VCL and FireMonkey apps, connecting devices, sensors, data, and services, and the applications you can create are really limitless. Let me also mention that XE7 has a new dedicated Bluetooth LE low energy component to work directly with Bluetooth LE. That makes it very easy for you to connect to different devices like wearables and gadgets. Now, I am not going to be covering this new Bluetooth LE component in this session, but there are other CodeRage 9 sessions you can watch that does cover this new Bluetooth LE component. So the industry in general is embracing app tethering, and now you can create apps for your customers for the Internet of Things, for devices, gadgets, and wearables. Let me quickly introduce two new XE7 app tethering features. Now, app tethering was first introduced in Rad Studio XE6 in both CBuilder and Delphi, and app tethering created a lot of excitement for both CBuilder and Delphi developers. All developers we spoke with loved the idea of app tethering, but some could not use it in XE6 because their Wi-Fi is on a separate subnet from their wide area network. And most companies have the same scenario, where many times your Wi-Fi is on one subnet and your desktop app is running on a different subnet, so your companion app could not discover the tethering manager on your VCL or FireMonkey desktop computer. So this is a great enhancement needed for enterprise customers for their enterprise applications. To resolve this limit, the XE7 app tethering functionality has been enhanced with app tethering supports connections outside your subnet. So in the previous XE6 release, the methods to discover remote devices to connect to, auto connect, and discover managers used to look for devices in the subnet of the local area network where the device running your application was. So as a result, you could not use app tethering to connect devices in different subnets of the same local area network or devices with completely different IP addresses. But now in XE7, both of these methods have an optional target parameter that you can use to override the default behavior and specify a target IP address or a subnet to search for remote managers. For example, we see on this slide, to specify an IP address to search for remote managers, you can specify that IP address as the target. So here we have IP address 192.168.127 as our specific target. Or to specify a subnet of IP addresses, specify an IP address with a 0 as its fourth number. So for example, in this case, we specified 192.168.1.0 as our target. So our manager searches the 192.168.1 subnet for remote managers. Now I'm also going to mention that you cannot specify wider subnets. So for example, I cannot have 192.168.0.0. That is not supported. The second new feature is adding support for Bluetooth tethering in addition to the network Wi-Fi based tethering we had in XE6. Now in XE7, app tethering works with either Wi-Fi network or Bluetooth, and this opens us up to many different types of new apps to create. The runtime library has a new unit called system.bluetooth that provides a multi-device API to access the Bluetooth features of the device that is running your application. This new unit provides support for both classic Bluetooth and Bluetooth Low Energy. You can now use app tethering to connect your application using Bluetooth in addition to IP connections. Now it's also important to note here is in XE6, if you use network Wi-Fi based application tethering, you can easily switch your existing apps now to use Bluetooth in XE7. The only change you need to make is to switch the allowed adapters property from network to Bluetooth on your Tether Manager component. You will also need to make this change to the Tethering Manager component on all tethered apps if you want to use Bluetooth instead of network Wi-Fi. For those of you that are new to app tethering, let me quickly go over these two app tethering components, the Tethering Manager and the Tethering App Profile. These tethering components follow the Bluetooth profile model. There is a main component and then a profile that implements the functionality. The Tethering Manager is the component that manages all basic operations such as auto discovering and pairing with other remote managers. The Tethering App Profile implements the application profile. It's a set of functionality that includes executing remote actions, sharing resources, and sending streams and strings between other paired profiles. Now a manager needs to register a profile to start. So you do need to drop a Tethering Manager component and a Tethering App Profile component on your VCL or FireMonkey form and then link both components, filling the Manager property in the Profile component. Now to find other tethered applications in the network, your app needs to execute either the Auto Connect or Discover Managers functions. Now using Auto Connect, this starts the automatic connection to remote managers on each registered adapter. Using Discover Managers, this starts the discovery of remote managers on each registered adapter. Now for both the Auto Connect and Discover Managers, for communications over the network, the automatic timeout is 1.9 seconds. And for communications over classic Bluetooth, the automatic timeout depends on the number of paired devices to the manager. On either function, you can set a timeout. The default timeout is 1900 milliseconds. So here we see a 2-second timeout to search for managers. When the timeout finishes, you receive the on-end auto connect or the on-end managers discovery event, in which you receive a list of the discovered remote managers. And then from this list of remote managers, you can choose the ones you want to pair with. Okay, at this time, let's take a look at a C++ Builder example on how to use app tethering for your VCL or FireMonkey apps using either Wi-Fi or Bluetooth. This is the sample C Builder shopping list app located in the RTL tethering folder. Let me first run the app and then we'll look at the code to see how we added app tethering. So this app will manage and update inventory of your warehouse database, VCL or FireMonkey desktop application that is tethered to a companion application either over Wi-Fi or Bluetooth. So you can extend your existing VCL or FireMonkey Windows applications to other devices, like a mobile client, without having to port your entire Windows applications. You can pick the features that make sense for, let's say, a mobile client, and easily interact with your existing Windows, VCL, or FireMonkey applications. Now, the Windows application is a database application. So each time an item stock is under its minimum stock value, a shopping list is generated and is sent to all of the connected app tethering clients. So I'm now going to click on the connect button of my client to app tether connect to the Windows desktop app. Now on the connect, my companion app, for example a mobile client, it's going to be the client that's going to receive the shopping list. So from here we can buy 100 units of an item by pressing the button. So for example, Jorge A needs 600 more items. So by clicking the buy 100, the order gets placed and the change gets reflected on the VCL or the FireMonkey desktop app and any other connected clients also. Now let's look into the code and see how we added app tethering to these applications. This is the C++ Builder BD shopping list sample app. For both the Windows desktop app and the client companion app, we added the two app tethering components. We have a tethering app profile and we have a tethering manager. So these two app tethering components, they follow the Bluetooth profile model. There's a main component, the manager, and then a profile that implements the functionality. The tethering manager is the component that manages all basic operations, such as auto discovering and pairing with other remote managers. The tethering app profile implements the application profile. It's a set of functionality that includes executing remote actions, sharing resources, and sending streams and strings between other paired profiles. So a manager needs to register a profile to start with. So that's why you need to drop both a tethering manager and a tethering profile component onto the form. And then you get to link both of these components, filling in the manager property in the profile component. Now on the tethering manager component, we have the new XE7 allowed adapters property that lets me switch from network Wi-Fi to Bluetooth. So in XE7, app tethering works with either network Wi-Fi or Bluetooth. So for this app, I'm going to use network Wi-Fi, but it's great to know that I can easily switch from network Wi-Fi to Bluetooth just by changing the allowed adapters property. Next, to find other tether applications in the network or Bluetooth, our client needs to execute either the auto connect or discover managers functions. So here I'm using auto connect. In the previous XE6 release, the function to discover remote devices to connect to used to only look for devices in the same subnet of the local area network where the device running your application was. Now in XE7, both of these functions, auto connect and discover managers, provides this optional target parameter that allows you to specify a specific target IP address or a subnet to search for remote managers. So in my case, I'm specifying a subnet of IP addresses. So I specified an IP address with a 0 as its fourth number. So in my case, my manager is going to search the 192, 168, 192.168.74 subnet for remote managers to find. My auto connect function has a 3-second timeout, and when the timeout finishes, I'm going to receive from the manager component an event called onEndAutoConnect event. And that's because I'm using the AutoConnect function. If I was using Discover Managers, then instead I would receive the onEndManagers discovery event. And this event is going to return to me a list of the discovered remote managers. And from this list of remote managers, you can choose the ones that you want to pair with. For the tethering manager, we added a password. So when you want to make a manager private, you have to fill in the password, because if another manager wants to pair with you, it needs to know this password to be able to pair. So if the manager is protected by a password, as in this example, then you're going to receive the event on request manager password. And here with the remote manager identifier and a password variable to fill. So you need to provide the password to be able to pair. Now if the password is wrong, then you're going to get this on-auth error from remote event. If the pairing is okay, you would receive the on paired to remote along with the on-end profiles discovery or the on-end AutoConnect event with all of the profiles found in that manager. So to repeat quickly, on our client, to be able to use the basic app tethering functionality, we added the tethering app profile component, and we connected that profile to the manager. And with this, you can now share data and actions with other profiles. Next, you add to the tethering app profile shared actions and/or shared resources. So let's look at the VCL database app. So this example uses a shared resource. And a shared resource is a container that stores a data value or a stream and its public name that is used in order to be referenced outside. For our VCL app profile, it has an event called onResourceReceived. And here is where we're going to receive the data. The app profile for the VCL app has a shared resource container with a resource name of res shopping list, with a res type of data, and a kind of shared. And for the for our companion app, if we look at its tethering app profile, it also has a resource container, but its kind is equal to Mira. It has the same resource name, res shopping list, and res type is equal to data. So as we saw before, clicking on the connect button of our client calls our manager auto connect function. And I have two more items to show you on this example. So the first item is I'm using a list view component here, and if I look at its on button click event, here is where we send the string by item to the connected tethered app. And the last item on our connected tethered app, our VCL desktop app, it's going to perform the on resource received event, and here is where we're going to add the 100 to the product stock value for the item. So now that you have an understanding on how app tethering works, let me quickly rerun our VCL database app, and I'll also start up the companion app and connect with our companion app. So on the connect, we do our auto connect. We search 3 seconds for managers to connect to. And what gets returned to us is our list of discovered managers. And we're going to pair with the manager we want to work with. The client receives the shopping list of items that are below minimal stock value. And then the on button click event of our list view on the client is going to send the string by item to our connected tethered VCL or FireMonkey desktop app. And on the resource received event of the database app, it's going to add the 100 to the product stock value for the item. So that works great. App Tethering Platform Support. The RadStudio XE7 App Tethering feature does not depend on a specific transport or protocol, and new transports and protocols can be implemented using the App Tethering API. The runtime library provides built-in support for IP and classic Bluetooth connections. The IP support also includes connecting applications running on the same device. So as we see on this chart, with the exception of no classic Bluetooth connections on iOS, App Tethering is supported on the 4 major platforms, Windows, Mac OS X, iOS, and Android for both IP and Bluetooth. And for Bluetooth App Tethering, I'll remind you that the only change you need to make is to switch the allowed adapters property from network to Bluetooth on your Tethering Manager component. You will need to make this change to the Tethering Manager component on all tethered apps. And if you did use network Wi-Fi based application tethering in XE6, you can easily switch your existing apps to use Bluetooth tethering in XE7. Now, before running the application to use Bluetooth, you need to ensure that both of your devices are paired. So in my example here, I'm using a Nexus 7 tablet that I paired to my MacBook Pro. On my Nexus 7, I selected Settings and turned Bluetooth on. I then clicked on Bluetooth and selected to search for my devices. Once my Nexus 7 found my MacBook Pro, I clicked on it to pair my Nexus 7 device to it. My Nexus 7 then also appears in my list of Bluetooth devices on my MacBook Pro. App tethering resources. So lastly, for some additional app tethering examples, look at the samples provided in XE7. So in this session, I showed you the BD shopping list app that shows app tethering sharing resources between other paired profiles. The media player app shows app tethering executing remote actions between other paired profiles, and the photo wall app shows app tethering sending streams between other paired apps. Also, take a look at the DocWiki under using app tethering for additional resources on how to use app tethering with XE7. So this ends this CodeRage 9 session on C++ Builder app tethering for VCL and FireMonkey using Wi-Fi and Bluetooth. So thank you all for attending. And now let's open up this session to any questions you might have.
James asked about, is there encryption with app tethering and what is on the roadmap? And Al answered, there's no out-of-the-box encryption, but you can do encryption before you do a send data, send streams, send string, and so on, and then do the unencryption on the other side. And Luis Felipe said, great feature, and we all agree. It brings life and extensibility to existing VCL apps, and especially if those apps have actions, then you can also fire actions remotely. So it's like your TV remote, right? You have those universal remotes, and you can command all sorts of things. Same idea in tethering. At the same time, you could tether to FireMonkey apps across different platforms. You could tether to VCL apps on Windows platform. So it's not meant to be just mobile to desktop or desktop to mobile, or again, in any application that you build, you can add app tethering. And you have the tethering manager and the profile components, and you can use them in a mix and match types of ways. I'm not the networking expert, so subnets and the slash syntax.
Yeah, that's a great question. I have not tested that myself. Now I know from my own personal experience that most ISPs don't advertise any subnet smaller than /24, but I understand you can split, let's say, a /22 IP block between various sites without having to use more IP addresses than you have. But I have not tested this myself to see if this works. Because yeah, so as we know, we use UDP to broadcast this discovery message, and we go across ports 2020 through 2040. So if we can find that subnet that's smaller than a /24, then in theory we should be able to discover it. But I myself have not tried to test that.
The other thing I've noticed, if you've got busy networks, you may need to update or extend the timeout, the discovery time, depending on how busy things are. And also, Wi-Fi is a little faster at the UDP, again, depending on your network traffic. Bluetooth is a little slower, so you may want to play around with that discovery time.
That's correct. Our default timeout on both Bluetooth and Wi-Fi, I think, is 1.9 seconds. So yes, as David mentioned, if you have a busy network or a lot of activity on the network, you may want to bump up that number. Or if you expect more managers to be returned that are not being returned, then that's another indication of increasing the timeout, just to make sure you collect all of the managers that you're able to connect to.
And then I remember talking with the developers about Wi-Fi versus Bluetooth, and as you showed in your demo, Bluetooth pairing, you need to pair, and they advise that you shouldn't pair too many Bluetooth tether apps like you might go out and explore through UDP, a whole host of apps that might be out there, because it'll take longer to find and discover those Bluetooth if it has to look through, a huge list of paired Bluetooth computers. So really, they recommended pairing just the computers that you're going to have tether apps on, and not pair with other computers, because it'll take longer and it might not find all of them.
That's correct, and I'm just going to repeat again, the app tethering I was speaking about in this session is classic Bluetooth, not the Bluetooth LE. So with classic Bluetooth, there's a lot of good things about it. You get a much faster data transfer rate, so if you want to stream data and video back and forth, classic Bluetooth works for that. But then the number of connected devices using classic Bluetooth, I've heard a number like 7 is probably the most amount of connected apps you want using classic Bluetooth, versus Bluetooth LE, low energy. You can have a large number of connected devices if you're using Bluetooth LE.
And Rob, we both answered and gave guidance to Rob. He was asking, gee, can I support both network and Bluetooth, or do you need to try both? And there's a couple ways to think about that. One is you could have a tethering manager, and you could connect and disconnect and change the property from Wi-Fi to Bluetooth, and then go and rediscover. But better, since one component manager can't go out and find everything it can find on Wi-Fi and Bluetooth. Better would be to put down two managers and then their associated tether profiles components, so that you could search for network in your app and search for Bluetooth and get the discovered devices on both and process through them. I think you can, as long as you're disconnect, switch that property in the tether manager. But once it's paired, quote unquote, even on Wi-Fi, the sort of virtual pair, you'll need to disconnect and if you want to reuse one manager component. So I'd prefer that you put two, but I'll play around with switching the tethering manager between the two settings and see what else I have to do. I think that'll be a good blog post.
That's correct. Yeah, so that's important to say. So I believe it's possible to drop two managers onto the form, and each can have one or more profiles. And then after the timeout period to either auto-discover or discover managers, you get the on-end managers discovery event and the on-end profiles discovery event. And then you're going to get all of the discovered managers with their IP addresses, their ports, and all of their tether profiles, and all with their own GUIDs. So then you decide which manager and which profile you want to connect to, either over Wi-Fi or Bluetooth.
Let's see, Senador was mentioning about, well, these apps have to be around, right? There's no launch on demand. They have to be sitting there listening to be tethered and commanded and so on. There's no auto launch from a registry or background or something like that. They need to be around, right, Al?
Correct. Yeah, correct. That adapter needs to be a registered manager sitting on either that IP address, or in the world of Bluetooth, you could be connecting to I think a MAC ID. Each of these devices has a MAC ID or a friendly username. Like I can either look for my Nexus 7 as a Bluetooth device, or the MAC address of a MacBook Pro. But yeah, they have to be out there already running.
No, I think that's it, Al. There was, again, just the comment from Rob about security, and I'll pass along to the team whether we should do something. Usually when it involves encryption, we sort of shy away from delivering anything specific, especially at the higher end of encryption, because then we need export licenses in the U.S. Interbase has the same thing. We ship DES, and then DataSnap, we ship some simple encryption as examples for encryption filters, but then we leave it to you to hook into things like crypto API for Windows or other systems.
That's correct. Yeah, as you're sending data or sending streams or sending streams, or you can encrypt, you can compress on one side and then do the opposite on the other side. So that's also possible.
Yeah, and there was a question about what can you stream, and you answered that one. And we have samples. You can stream pictures.
You can stream any data type. You can stream.
Okay, Al, thank you very much. This was great.
My pleasure. All right, have a great day, and thank you all for attending.
Yeah, and I love the app tethering stuff. It's just real.
Yeah, the simplicity of it, I love it. Just be able to drop, take an existing VCL FireMonkey app, drop those two app tethering components on it, and auto connect, and you're good to go. It's that simple.
One other thing I'll add is there are some additional events that we usually don't demo. For example, there's an event if the tethered app you're connected to shuts down, the computer shuts down or whatever, you'll get an event that'll fire so you can know that you've been disconnected from one tether client to a tether target and so on. So there's other events that we don't normally play with. Just go look at Tethering Manager and the profile and look at all the events to make sure you find the ones that you want to hook.